In this video, we want to review the Chapter 1 test. So, Part A is all things are looking at this diagram here. Okay, so get a pen. We're looking in reference to the segment QR. What is parallel to QR? XW is parallel to QR. Done. Which is skew to QR, XW is parallel, UX is skew to QR. And which are the following intersects with QR, RS is intersecting with QR. Which plane is the intersection of QRST and RSBW? Well, you can see that they both contain RS, so that is the value of the intersection. If two planes are not parallel, then they are perpendicular. False. Okay, if they're not parallel, does not mean that they have to be meeting. They do meet, they intersect, but they don't have to meet at right angles. Given the area of the circle, you can always determine the circumference. This is true. You have an exercise on the last page doing the same thing. Given the perimeter of the rectangle, you can always find the area. False. I could say that the perimeter is, let's say that the perimeter of something is 24. Well, I don't know necessarily how the area is going to break down. I don't know. I don't know what lengths of the sides, okay, they are going to be. It could be any infinite number of combination. This is a statement's always true for a midpoint. Okay, any segment A, B, midpoint at M. Certainly, AM is half the total length. That's exactly what that says. Well, angle addition. Any two adjacent angles forming opposite rays. Well, opposite rays is another name for a line, and adjacent angles are next to each other. So these are two opposite rays. These are two angles formed by opposite rays, and they are supplementary, adding to 180. Any 3 points are sometimes collinear. Point, point, point. They don't exist on one line, okay? Any 3 points are sometimes coplanar, okay? These 3 points are coplanar, but you could have another third point down here, which makes them collinear, so it's a sometimes. Any 3 planes will sometimes intersect at one point, okay? Look at the coordinate system, the X, Y, and Z coordinate plane. You had a graphic of that in one of my videos, okay? The 3 planes intersect at the one point, the origin. Look up at the corner of the room where 2 walls and the ceiling meet. That's a single point where 3 planes are intersecting. Okay. Many of these problems, section D, are coming right off of the worksheet on angle addition, segment addition. State the geometric statement PT is congruent to TQ. Little slashes tell us there. Set the values in. Solve for X. X is 22. You're done. Okay. This is angle addition here. Okay. Angle addition. We know that the sum of the 3 angles, AOB, BOC, and AOD, is equal to the all-inclusive angle, AOD. So we make that statement. We know here that we have these angles congruent. One is given as 28, the other is 28. So put in the values, 28 plus the BOC angle, which is 3x minus 2, plus another 28 is equal to 6x. Add the like terms, 54 plus 3x equals 6x. Subtract the 3x, okay, and that should be 3x there, okay. X is equal to 18. All right, here's a segment AB with midpoint M. You should draw it if you need to. So obviously AM and MB are equal. If you get that right, you should get everything else right because it's a simple equation from there. Solve for x equals 8. Midpoint and distance formula. Okay, write them down. X1 plus X2 over 2, comma Y1 plus Y2 over 2. Put in your values. The midpoint is 1 comma 5/2 or 1 comma 2.5. Apply the distance formula. Write the formula out. The square root. Quantity x1 minus x2 squared plus y1 minus y2 squared. Put in the numbers. Minus the negative turns positive. That goes to 10 squared. Plus 1 squared, 101, the square root of 101. Leave it. That's fine. Nothing here needed a calculator. Not a single problem here needed a calculator. And I would have been happy with just 101. It is a little bit over 100, but I'm not going to worry about it. Okay? This is the problem where the midpoint is given and one endpoint is not. One endpoint is unknown, so its coordinates are xy. So again, I used the midpoint formula from the previous problem, although it sets up -4, so the setup here is -4 plus x over 2 is 9. There it is. And 7 plus y over 2 is equal to 12, -12. There it is. We solve it. For x and y, we get the coordinates of the endpoint, not the coordinates of the midpoint, at 22, -31. That's why I asked you to construct this so you could visualize what was being asked for. Okay. Here's a problem right off of our worksheet. The perimeter is distance around. Does not include this piece, okay, which some of you included. So it's two lengths of 20 and a length of 10 down here, and 1/2 the circumference. We identify the radius of the circle as 5 because it's half this length, half this, which is the diameter. So it's 50 plus 5 pi, and that is left alone. I told you, leave pi as pi. Area is the rectangle, 20 by 10, plus half the circle, half of pi r squared, half of 25 pi. There it is. Leave pi alone. This, the classic yin-yang symbol. Okay? The fact is, the darkened area is absolutely 1/2 of the large circle. The black area and the white area are equal. Okay? So even this little circle here. Okay? You say, oh, this little portion is missing, but this one would fill it in, so it's still half. The circle has a diameter of 8 inches, which means that the radius is 4. Pi r squared is the area of the circle. 16 pi, but we only want half, so we want 8 pi. Okay, number 3, exact problem from the worksheet. Perimeter. Okay, this side over here is comprised of a length of 2, 3, and 2, which means that's entire side is 7. The bottom, the base, if you will, is combined with 5, 3, and 4, whose length is 12. So the perimeter is simply no different than the perimeter of a rectangle. 2 lengths and 2 widths. 2 times 7 plus 2 times 12, 14 plus 24, 38. The area. The area is the overall figure, rectangle 7 by 12, minus the 2 smaller rectangles, a 2 by 3 and a 5 by 4. 7 times 12 minus 2 times 3 minus 5 times 4, 84 minus 6 minus 20. Area is 58 square units. This problem, almost the same problem as shown in class. Each circle has a radius of 2, diameter of 4, 4 diameter, 4, 8, 12 is the base of this rectangle. 4, 8 is the width. So the rectangle is 12 by 8. The shaded area that we're after in here, all the gray area, is the total rectangle area minus 6 times the area of each circle. So that's length times width minus 6 times pi r squared. Remembering r now is 2, so 4 pi. 12 times 8, 96, less 6 times 4 pi, 24 pi. This is a problem we had on the front page. The area of the square is given, the perimeter can be found. Just use the formulas. Area is equal to side squared. It's known as 169 side squared. Remembering your perfect squares, says the square root of 169 is 13. The perimeter is 4 times the length of one side, which is 4 times 13, which is 52. Another one, very similar. The circumference of the circle is 18 pi. So circumference, which is given by formula 2 pi r, is 18 pi. We solve for r, we find r is 9. We want to know the area. The area is pi r squared. The radius is now 9. So the area is 81 pi. Leave it in terms of pi. This is the exact value. This problem, one of our problems from our textbook, but changed up a little bit. Okay, I'm after the area in gray here, which I want to perhaps put a new track down. I want to know what is the area of that. So, so it makes sense that the area I'm after is the outside area, the total figure, minus the area in green. So it's going to be the total figure minus the area in green. And so if we look at the total figure, it's consisting of a rectangle. Total outside figure is a rectangle whose dimensions here are 100. And then the outside width is 60 because it's 40 on the inside here and 2 bands of 10. And the outside radius would be of, since this width is serving not only as the width of the rectangle but the diameter of the circle. The diameter is 30, the radius is, the diameter is 60 and the radius is 30. So here you have it. The outside is a rectangle 60 by 100, which is 6,000, plus the radius squared pi, which is 30 squared is 900 pi. Now the inside, the area in green, is the rectangle 40 by 100 plus the circle radius 20. So it's 4,000 plus 20 squared is 400 pi. So now what we want is the difference between the two. So the area of the track is, as you say here, the outside minus the inside. Subtract your like terms. 6,000 minus 4,000 is 2,000. 900 pi minus 400 pi is 500 pi. So there is the area, and that is fine. You leave it exactly like that, and that's the exact answer. So there's your solutions to your test. So you should go over this and make sure you're clear on all that, because you'll see it again when it comes time for the exam.